Hello, class. This will be our second video from chapter 2, specifically 2.2, which is subsets. This should be a little bit shorter version video than the last time. Uh, section 2.1, I think, had 17 definitions we needed to go over. So section 2.2, definitely fewer definitions, but we're going to lean heavier into how to apply the definitions, and get a little bit more serious and like the how the question is and can you apply the definition. All right, so just like last time, or as always, I'm going with the lecture note outlines. We're doing 2.2 subsets, and I also have a few, that definition paper I typed out for you. We're going over that as well, and then I will also get into MATLAB and see how those questions are worded. All right, so let's jump into the notes. All right, so 2.2 is all about subsets. And so this is where this is one of those definitions that gets confused a fair amount because of the way we use it in English versus the mathematical definition, sort of like Ward causes problems. Um, we'll come to that in 2.3. But what is a subset? Well, just from the sound of a subset, it sounds from English that it's like a smaller part of a larger set. So the problem with that, from the math standpoint, is that's more of a proper subset. Okay? So when we think subset, most of the time we're actually thinking proper subset. So we got to be able to make sure to keep the difference between those two. All right, so what is a subset? Now I'm gonna, sorry, got it written out in the other sheet. I'm not gonna write it out again. But let's go through this. Okay, so A is a subset of B if every element in A is also in B. So every element in the first set has to be in the second set. Okay, the notation, it looks like an elongated C with a bar under it. Okay. Now, I don't know if you noticed this right off the bat, but to me, that looks like a lot of that subset symbol looks a lot like less than or equal to. And that's not coincidence. It's there for a reason. So if we have a subset where every element in A is in B, the notation is A is a subset of B. We always read this from left to right. We don't care so much about what's in B. We care about what's in A and how it relates to B. So B can be a lot bigger or maybe a little bit bigger, or it can be equal. So that is the actual definition of a subset. Now, a proper subset is one, A is a subset of B, because you can't be a proper subset if you're not a subset to begin with. So A, every element in A is still in B, and so a proper subset has one extra condition, A cannot be equal to B. So the notation for that is that elongated C without the bar underneath. So A is a proper subset of B. And then again, this looks like less than for a reason. And so it's very common for students to not pay attention to the difference of these and get them mixed up. And just know that this is one place where I think where English really kind of throws us off, because when we hear the word subset, we tend to think proper subset. So you've got to know the difference between these two, and the notation is a clue because it's just like the inequalities we talked about, which is one of the reasons I didn't mind doing that earlier in this unit, is that looks like less than or equal to. So a subset can be equal to the original set. A proper subset has no equals, so a proper subset has to be strictly smaller than the set we're talking about, or the set it's coming from. All right, well, and we'll come up to this at some point, but by definition, the empty set is a subset of every set. Like I said, just take that by definition, and you'll see what I mean when we get to homework problems on that. Okay, so let's get into the actual type of problems we'll see. Concept wise, that's pretty much it from 2.2. Now we just got to be able to do homework on it. Okay, So these style of problems are going to start to look more like we'll get into in 2-3. So we're transitioning from just pure multiple choice to like into Venn diagrams. So we'll talk about this. So this sort of setup is not uncommon. So we're going to have we have set A, B, C, D, and U. And U, if you notice, is the biggest set. That's not coincidence because U is our universal set. Remember, when we talk about universal set, it's the set where everything has to belong to. So if you look at A, 1, 3, 5, 7, there's 1, 3, 5, 7 in the universal set. B is 5 through 8. So 5 through 8 has to be in the universal set. C and D, same way, is both of those, all those elements have to be in the universal set. Okay. So one of the things that, this section in particular has a lot of true and false. I really wish, what I don't like about true and false, people tend to guess and then move on without kind of showing their work. And if you think there's no work to show, the why you chose true or false is actually your work. So like when it comes test time, if it's true and false question, if you want the chance for partial credit, if you'll write me a sentence or two of like why you chose that, and you get it wrong, then you still have a chance for partial credit. And because the reason that you're choosing it generally goes back to the definition. Do you know the definition or not? Are you applying the right definition? So there's reasons why you're choosing this, hopefully, rather than just pure guessing. All right, so let's go through this. Okay, so determine if the statement is true or false, and if it says if false, explain why. We'll explain either way. So first of all, you have to be able to read this. Okay, so that you have to know that is a subset symbol because of the equal to. So this is saying, is C a subset of D? Well, here is C. It's the set 5, 8. And D is the set 2, 5, 8. So how do you answer this question? Right. So you have to know, one, that says subset, and then two, what is the definition of subset? So that means that everything in the first set, every element, every item, or element has to be an element in the second set. So is every element in C also in D? Well, 5 is in D, 8 is in D. So both of those are good. We don't care about the 2 because we're starting with C. C doesn't have 2, so we only care about the 5 and the 8. Okay. So therefore, this is true. Because every element in C is in D. All right. What about B? Let's start 3. Is D a subset of B? So that's saying, is every element in D in B? Okay. Well, we already have D written. B is 5, 6, 7, 8. Okay. So the problem right off the bat, 2 is not in B. 5 is and 8 is, which is fine. But since 2 is not in B, this is false. If we wanted to use symbol, we could say that's our subset symbol. And then if we put a slash through it, but then we could say D is not a subset of B. So we might use that notation with that slash through it as well. All right. Well, this isn't a subset question, but it's a notation question. So how do you read that? Well, A is not equal to 7, 5, 3, 1. So what is A? A is 1, 3, 5, 7. So is this true or not? Well, it's false because order doesn't matter. So this is saying, A is 1, 3, 5, 7. So this is true. Or so, A, this is A, so the not equals makes this false. So that's one thing I don't like about true and false. Sometimes they almost feel like they're playing games with that. So you just got to slow down, be careful when you read it. All right. So number 5. So this is where, knowing how to read this is important. And so this is not the number 5. This is the set where 5 is an element. So is that a subset of D? Does every element in here also in here? Well, we know D is 2, 5, 8. Okay. And so the element here is 5. 5 is also in 8. That's good, so that would be true. Okay, now let me show you how that could be false. I mean, there's a number of ways, but what if I gave you this? So I didn't put the curly brackets. So is 5 an element, a subset of D? Well, this is not a set because there's no brackets. So that is just an element. This is false. Now, if we said is 5 an element of D, that would be true. There's no brackets means it's a single item, a single element in the, because D is 258. So that's a single element in D, so that's true. That is not a set. So if it's not a set, it can't be a subset. Okay. So this is the many different ways that we can play with you on this true and false. Okay. What about 6? Is the set 0 a subset of the universal set? Well, if you look at the universal set is 1 through 8. 0 is not in there. That would be false. Okay. So, I don't know if you can read that or not. It's a little light. So this is saying D is not a proper subset of D. So can D be a proper subset of D? Well, how do we define proper subset? Well, proper subset, again, go back to the definition. The one, it has to be a subset. So every element in D is in D. So this is a regular subset because every element is over here is in here. But to be a proper subset, the other thing we have to know is they can't be equal. So D cannot be equal to D to be a proper subset. So that makes, so that says D is not a proper subset of itself. So that when it says not a proper subset, that's true. Because it's basically, so this is double negative. If we just said, is D a proper subset of D, that would be false. Because D is equal to D. So if we said it was a regular subset, that would be true because D can equal D. It doesn't have to be smaller than, it can't be equal to with a regular subset. Okay. All right. So like I said, once you start putting a slash of those are negations. And so a lot of times you end up with double negative sort of things that can make the true and false kind of tricky. Okay. What about 8? What is a bracket with nothing in it? That is the empty set. So is the empty set a proper subset of C? Well, go back to the definition. So to be a proper subset, every element in here in the empty set has to be in C, and they can't be equal. Well, C is 5 and 8, so the empty set, so C is not equal to the empty set, so they're not equal. Then what about every element in here, and the empty set being in here? Now, that may seem strange. That's why we have that definition. I pointed out that every set is a subset of every set. So empty set is always a subset, right? And so since it's not the empty set over here, then it's not equal, so therefore it is a proper subset. The other thing to point out is all sets are subsets, but not proper subsets of themselves. They can't be proper subsets of themselves because the equal part, that's kind of what we were talking about there. So the empty set is a proper subset of every set except the empty set. It is a regular subset of all sets. Fun, right? But this is what you need to be able to do in chapter 2 to be successful, is now we're applying logic. Okay. All right. So another way to ask this, rather true or false, is use subset, not a subset, proper subset, or both to make a true statement. Okay. I kind of don't like this because if you're a proper subset, by definition, you're also a subset. So proper subset has to be a subset and not equal. So it's, I don't know why they give us proper subset when they say both. Okay, because by definition, if it's a proper subset, it's also a regular subset. Okay, but let's go through. Okay, and she. So first of all, is 6, 7, 8 start with a subset? Is it a subset of 5, 6, 7, 8? Is everything on the left also on the right? Yes. Okay, so that makes it at least a regular subset. Now, is it a proper subset? Are they equal? No, because this one has 5. So this one would be both is a proper subset and a subset. So how about 11? Well, every element over here on the left is on the right. So that makes it a subset. Can it be a proper subset? Well, proper subset means they can't be equal, but these are equal. So it can't be a proper subset. It is only a regular subset. All right. And again, that's why I say you have to go back to that definition over and over and over again until you get it burned into your synapses. All right, what are we going to do with 12? Well, first of all, we're going to figure out what sets we're talking about. So this is the set X such that X is a natural number. That means it's positive, and X is greater than 8. So on the left, where do we start? Well, greater than 8, it's not equal to 8, so it starts with 9. And 9, 10, 11. There's no ending point, so it goes on forever. On the right-hand side, we have X such that X is a natural number, so we're dealing with positives. And 4 is less than X, which is less than or equal to 8. So what are we dealing with on the left-hand side? Or sorry, the right-hand side? It's not 4, goes to 5. It starts at 5, now it equals 8, so 5, 6, 7, 8. Here. So now that we know the elements, is the left-hand side a subset of the right-hand side? Definitely not, because there is nothing in this set that's over here. So this would not be a subset. It's not a subset. We don't need to continue because it can't be a proper subset without being a regular subset. Okay. What about 13? Well, 13 is just like 11. Those sides are equal. Right? So everything in the left is on the right, and it's equal. So it can only be a regular subset, not a proper subset. Because proper subsets can't be equal. All right. And then after we go through this, then we'll get into Math Lab and look at some different style problems. Okay, so the other kind of concept in here for 2.2 is the number of distinct subsets. All right, now if you really want, so this is like the one, there might be a set, I think there's one other formula in this unit that you need to have memorized. You will have one side of one page of notes allowed for this test. So you may want to write this formula down. So the number of distinct subsets in a set is 2 to the n power. If you want to know why, we have to, that would be under probability, which is chapter 11, which we're not covering this semester. So just take it, as a rule, number of distinct, which means different subsets, is 2 to the n. The number of distinct proper subsets is 2 to the n minus 1. Well, where's that minus 1 coming from? Well, they can't be equal to each other, so we have to subtract 1 from that answer we got for number of subsets. All right, so I'll explain this a little bit when we get to 21, but really, I think I took these out of 21 because they end up being all multiple choice, which kind of took when you're listing subsets, MATLAB doesn't do a good job of that, so we're going to stick with the number. All right, so how do we determine the number of subsets in the set 10, 11, 12? Okay, well, we're doing subsets, so we're doing 2 to the n. Well, what's n? Well, n we've seen it, a number of n elements. We've seen that before with cardinality. So that's how many elements are in this set. Well, there's 1, 2, 3. So we're doing 2 to the third. And like I said, this is where we do a little bit of arithmetic. 2 to the third is 2 times 2 times 2, which is 8. So there are 8 subsets in that set 10, 11, 12. Now it doesn't ask for it, but if we wanted proper subsets, well, we would just subtract 1. And so the number of proper subsets would be 7. Okay, determine the number of subsets in the set 0. So we're doing 2 to the n. So we need to identify n. How many elements are there? There's not 0. 0 is the element. So that means there is 1 element. So n is 1. So now the number of regular subsets would be 2 to the first, which is 2. If they wanted proper subsets, we would subtract 1 and get 1. Okay. So how about number 17? Determine number of subsets of, that's an empty brackets, that's the empty set. So how many elements are in the empty set? Well, there are none, so it's n to the 0, or so n is 0. We're doing 2 to the 0, which if you've done your exponent rules homework, we've talked about the rule of 0 exponent. So 2 to the 0 would be 1 by definition. If we want proper subsets, 1 minus 1 would be 0. Okay. So one more, and then I'll kind of explain that rule a little bit. What do we mean by all the subsets? So I think that'll kind of clear this up a little bit, and then I think you'll be glad that you don't have to list them all out. All right. So number 18, at Mega Salad, salad can be ordered with some, all, or none of the following sets of ingredients. We have ham, turkey, chicken, tomato, feta cheese, cheddar cheese, cucumbers, onions, red peppers, hot peppers. How many different variations are there for ordering a salad? When it says how many different variations, it's asking for number of subsets. Because you could have a salad with everything, you could have a salad with no toppings, or any combination in between. Right? And all those different combinations are one type of salad. So that's like one element. Each type of salad is like one element in the whole group. So first thing you have to, once you recognize that's why we're talking about subsets, then you need to figure out what is in. And then when I do this in class, we always have to count it twice. So be careful here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm getting 10 toppings, so it's 10 elements. So we're doing number of subsets, it's 2 to the 10th. This is where you grab a calculator. 2 raised to the 10th power is 1024. So with 10 toppings, you could potentially have 1024 different salads. Now that's subsets. If they want a proper subset, which means they didn't let you put all of them on at the same time. You could have, only 9 out of 10 basically. Then there would be one less, it'd be 1023. I don't know how many of you are Sonic fans. I remember, I don't know if they still talk about it, but I remember the commercials where they talk about all the different additives you could put into the flavors you could put in their drinks, and there was like millions of possibilities. Same idea. All right. So when we're talking about all these subsets, what does that mean? Okay. Well, I'm going to give you one example, okay, and show you kind of where these numbers are coming from. And, you're not going to have to do this yourself. I don't think I put any of those in the homework. If there is, there'll be multiple choice. So list all the subsets of wolf, cat, and sheep. Well, first of all, how many subsets are we dealing with? Well, we have 3 elements. This would be 2 to the third. So there should be 8 subsets of this group, of this set. Okay. Now, to simplify this up a little, I'm just going to use WC and S. So I have to write them out every time. So when it says list all the subsets, there should always be 2 subsets you list. One is the original set, because every set is a subset of itself. and list the empty set, because the empty set is always a subset. So there are 2 of my 8 sets. Now, how do we get the other 6? Well, I've done one with all 3. I've done one with none. Now we have to do the subsets that have 2 elements. So we have wolf and cat. We have wolf and sheep. Now we can't do wolf with anything else, but we can do cat and sheep. Now you may ask yourself, well, how about cat and wolf? Is that a subset? Well, yes, but we've already done it because remember, order doesn't matter. So don't mess up the order and think you have a new subset. Okay, so that's the only way we can pick 2 elements out of this set. So what about 1 element? Well, we can do wolf by itself, we can do cat by itself, and we can do sheep by itself. Okay, so we've done all 3. We've done all the combinations with 2, done all the combinations with 1, and then the combination with none. How many does that give us? 2, 3, 4, 5, 6, 7, 8. So that is where those 8 subsets are coming from that this formula gives us. All right. Let's do a couple of these and then we'll jump to the homework because in the homework there's more like this. All right. So if the statement is true for all sets C and D, write true. If it's not true, then write false, and then we'll explain it. So we're going to assume that C is not the empty set, and the universal set is not the empty set. And we're also assuming that C is a proper subset of U. So we're starting already knowing neither is empty, and then every element of C is in U, and C is smaller than U. It can't be equal. So is the empty set a proper subset of C? Well, we know the empty set is a subset of every set, so that part's true. It's not equal because C is not the empty set. So that's true. So how about this? If C is a subset of D, sorry, a proper subset, there's no equals. So if C is a proper subset of D, then C is a subset of D. Is that true or false? Well, that's true because for C to be a proper subset, number 1 is it has to be a subset. So this is true. But you can't be a proper subset if you're not also a regular subset. Yep. All right. Let's see. We've already done 25. We talked about that. How about 26? If C is a regular subset of D, then C is also a proper subset of D. Well, if you don't know, so we know it's a regular subset. So to be a proper subset, 1 has to be a regular subset, which is true, and then they can't be equal. Do we know if they're equal? Well, it could be because there's equals there, but we don't know for sure. Since we don't know for sure, we have to assume false. The only time you can say true is if you know in every single instance it is true. If you can come up with 1 case where it's false, then in math that makes it false. Something can be true 99 times out of 100, but if it's false 100 times, then overall it's false. All right. And we'll talk more about that when we get to truth tables. And then, yeah. So how about 27? C is a regular subset of U. Well, is that true? Well, what do we know about C and U? Okay. Well, we know C is a proper subset of U. So to be a proper subset, that means 1 has to be a regular subset, and 2, they can't be equal. So that's saying, is it a regular subset? So yes, because we already know it's a proper subset. All right. So this is what I mean by you have to know how to apply your definition. And assuming you haven't seen this before, which most people haven't, it takes practice. So let me get into MATLAB and show you a few more variations of this. This is in the 2.2 homework. Let me just jump in a random one. Come along. All right, so write subset or not a subset in the blank. So this is true. All right. So we have, well, the words are written out, but it's, they got commas, so each letter is its own thing. So 11 plus 2, is that a subset of 12 plus 1? Okay. Well, don't get sidetracked by all the fancy stuff. What is the definition of a subset? That every element on the left set has to be an element in the right. So is E, so E is over on both. L is in both. We don't care about the repeats, so I'm going to skip the second and the third E. Is V is on the left, D is on the right. We've already done E, N is on both sides, so we're good. P is on both sides, so we're good. We've already done L. U and S are over there. And then T and W, there's T and W, and then O is on both sides. So every element on the left is an element on the right. So that is a subset. Because this is basically asking your definition. So all the elements in the first set are in the second set. That is exactly the definition. Okay. So this is, in the homework, you're going to get questions that are, do you know the definition? All right. How about this one? Determine whether it's a regular subset, proper subset, both, or neither, to make a true statement. And again, if it is a proper subset, then it is both. Yep. All right. So T is in both, R is in both, V is in both. So every element in the left is on the right. So this makes it a regular subset. So now the question, is it a proper subset? Well, proper subsets can't be equal. These are not equal. So this is both subset and a regular proper subset. Okay, sometimes they try to get fun here. Let's see. So set X such that X is a person living in Massachusetts, and then the other set is a person living in a state with a border on the Atlantic Ocean. So you kind of have to know, know your U.S. map that, Massachusetts does border the Atlantic Ocean. So that is true because somebody living in Massachusetts is good. Are they equal? Well, there's a lot of people living in the Atlantic Ocean or border on the Atlantic Ocean. People living in New York and Florida, North and South Carolina, Vermont, so the group on the set on the right is much bigger. So this is both. All right. So determine whether the statement is true or false. And so this is the set 0. Is that an element of the set 0, and the set 6? See, this is where, I think sometimes they can true and false. They try to get, um, I don't know what the word is, but there's a set O over here. There's a set of 0 over here. So that is one of the elements in that set. So a set can be an element because over here, now where that would be, let me back up. If the 0 and the 6 were not in set brackets, if it was just the set 0, 6, this would be false because that is a set. And so the set is not the same as an element. And to be honest, I'm not overly fond of that question. And so that is a little tricky. That would not make a good test question. Okay, what's the difference between a proper subset and a regular subset? I'll leave you to answer that one. So for a given set, first calculate the number of subsets for the set and then calculate the number of proper subsets. All right. So how do you calculate the number of subsets? Well, that's where you use the formula 2 to the n. And so you have to know that the n is the number of elements. So there's 1, 2, 3, 4, 5. So n is 5. So the number of subsets is 2 to the 5th, which, I think it's 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32. 32 Yeah, so that's 32. And then once you answer that, what's the number of proper subsets? Number of proper subsets is always one less. It'll be 31. So same idea. On something like this, set x, such as x is a natural number, and 4 is less than x, which is less than 9. Make sure, the trick here, or not the trick, the key is figuring out how many elements we're talking about. So since there is no equals, we're not talking about 4 and 9. So this is just 5, 6, 7, 8. So there are 4 elements, so you're doing 2 to the 4th. Oh, the very last one is list all the subsets. And so we want the subsets where we have just one element. And so that means we're doing 2 to the first. That means there are 2 subsets. So the first subset is always itself. So any set is a subset of itself. And then what's the other subset of every set? The empty set. Or if you notice down here at the bottom, there is that subset, or sorry, empty set. Let me try this and see if it takes it. Yeah. So I didn't have to put in the empty set, but so you're not going to get one like the Wolfcat sheet. Oh, that was a little bit too long. All right. So like you said, this is all about being able to apply definitions. Okay. All right. Like I promised, this is a relatively short video. Depending, the homework being short really kind of depends on how you're transitioning into learning and applying your definitions. So next up, we're going to get into some operations and Venn diagrams with the next video. So we're going to kind of, like I said, right now we've been talking about our vocabulary. Now we're going to start putting them into sentences and, getting a little bit more involved with them. That'll be next video. Okay, have a good day.